Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Waalaikumsalam, sir.
Okay, how are you? How's everybody? Okay. All right. Now, before we start, I would like to discuss about the homework, the one that you submit last week, the individual homework. So let's go through that thing. I would like to go through that. Okay. I will show you. Okay. So this is how we do the homework. First, I think we did this in class, but when I receive the answers, it doesn't seem that you do it in class because you look like very different. Okay, anyhow, this is how we do it. Okay, first you tabulate the information, and then X is the location, Y is also location. But you need to put the units. Okay, so we did discuss this. What is X and Y? It's location 1 and 2 in what? In terms the number of days. So you don't just label X location 1, Y location 2. You have to mention the number of days. I think I make myself clear on that one. And after that, you come up with the cost. Okay. So when you come up with the cost, you have to show how you come up with the cost. I did that. Okay, but you didn't do it. How did you come up with the cost? Cost is AX plus BY. And then it's given A 500, B 800. Then you come up with the 500X plus 800Y. So most of you, what you did is you just come up with the cost right away. So how you do that? Right? And then you have the inequalities. Okay, suppose can you mute your mic? Okay, you have the inequalities. And then you have to state the problem. Okay, like what I did here. I think if you did in class, we should understand this. I talk about this. Minimize cost, which is the function, subject to the constraints which we just obtained. So you should put right down here, minimize the cost, subject to the constraints which are given. Okay, all right, next. You want to find the intercept. Okay, so this is how you find the intercept. You look at the corresponding equation, you get the x-intercept, you got the y-intercept, and so on. And then you do it for each of the equations. Okay, there are many people who skip that part. After that, you draw the graph. Okay, you draw the graph, you draw it nicely. Okay, you put it, some people use 50, some people maybe use another interval. But you have to label up the, what do you call it? The feasible region. Now, what is the feasible region? The feasible region is the area bounded by this line, the y-axis, point A, point B, point C, and then point D. So if you have this graph wrong, okay, I would like you to do the correction now on your paper. Like this student here, okay, you have the feasible region wrong. So go back to your answer here, redo it, relabel the correct feasible region. Okay, feasible region is the one that is open area bounded by the point A, B, C, D. Okay, and then the y-axis, the x-axis, that is the region. Okay, so that is open bounded or open region. So there are 4 corner points, A, B, C, D. Now you have the 4 corner points. You tabulate the points. Okay, tabulate the point. But before you tabulate the points, we need to find. Okay, so you will find. You say here. Find. You have to write something. Not write an essay, but write something to explain what you are doing. So you say find point B. You don't say B equal to this. B is not equal to 13x. So it is not right to say that. Okay, I didn't teach you that thing. What I thought is getting the system. You don't say B equal to whatever 5x plus 8x equal to 4,500. That is wrong. You are not, this is not what you want. What do we want? You want to find B. Okay, so in order for you to find B, what do? We do the system of equation. All right, so it not B equal to that. So we should say find B. Find B, or you can say to find B. And you put in the system. Okay, the system which are what? Which are okay, where is the answer? Which are which are 13x plus 6y equal to this, and then 10x plus 20y. So you have, okay, another thing, you can label the lines, okay? This line here is what? Question number 1. This line here is number 2. So that when you come up with the problem to find that point, you don't mix up, okay? We don't mix up. That means we don't put in the different equation, the wrong equation. So you have this system, okay? 13x plus 6y. So I will just write it down. Point B, you got whatever the equation, call it 1. Question number 2, call it number 2. You don't say B equal to this, okay? You say you want to find B. After that, you solve. Okay, so how do I solve? You just say by substitution. Okay, so again here, from number 1. All right, from number 1, I got this thing here.
F prime x. Okay. F prime x equal to df over dx. Okay, remember just now the first step. The first step is you have to copy all the question here. The question is 3 of x squared. Okay.
So you have y equal to this, and then you substitute into number 2. All right, so you say from number 1, you got y equal to whatever, and then substitute into what? Into number 2. Now, that is a system of doing, so that you know what you do and how you do it. Otherwise, how did you do it? Okay, so substitute. You got this thing here. You got x equal to 60, and then how do you get 70? Don't express. Okay, I told you, you have to show all the steps. You can show me extra step. Okay, show all steps, and you can show extra, but don't do express. Okay, don't jump. If you jump, that means you didn't do it yourself. You get it from someone. Okay, because jump, you just give the answer. That means you get it from somebody. So you got find point C, same thing. Macam ni pandai pula tu. Okay, you substitute, you got y. So you have to do it this way. You substitute the x into the other equation, you got the value of y. So that is the point C. Okay, I do the table, but the student don't do the table, it's okay also, as long as what? As long as you do the substitution. You give point A, but you don't equate point A. Okay, point A is not equal to this thing. Okay, we are doing the substitution of point A into the cost function. So that's why I put the table. Okay, it is not equal. Point B is not equal to 86. It's the cost equal to 86,000. All right, but you have to modify the table. Don't do like this. Okay, point C equal, it is not right. And then from here, we identify the point. So that is the lowest point. So what you do, you conclude. So 60, okay, so minimum cost. So basically, this is how we do the question. Okay, so you go through your answers. If you have everything like this, give yourself 9 marks or 10 marks. But for this one, okay, which is the sample answer here, a few things that you miss. So you don't give yourself 10, okay? You give yourself probably 8 because you miss the problem here. And then you make B equal to this, it's wrong. Everything else is okay. So for this one, maybe 9 or 8. Okay, all right. And many people send late. Okay, for those people who send very late, you will get 0. Okay, thank you for submission, but I'm not going to give you any marks because we did that in class and I asked you to submit right away. Okay, as it is. But you submit late, everything is expressed, you know. So I did not know what you did during the class time, which I asked you to do the homework. Okay, all right. So that's the homework. Okay, now I would like to go a little bit about your name. Now, when I look at your names,
Sir, sorry, sir. Sir,
yes, yeah, yes. What is it? Okay, go ahead.
about the homework, hari tu saya cakap paling lewat pukul 10.
Yeah, for those people who have classes, who have classes after 5. But if you don't have classes after 5, then you should submit late lah. Or did I say 10 o'clock?
Yes,
But
because all of us excuse you because we don't find the feasible region.
okay lah.
Then you said you can submit it
I said 10
before
o'clock.
10.
I said 10 ke 8 o'clock?
10, sir, 10.
10, sir. 10.
Yes, 10. I very confirm.
Okay, so 10. All right. And this one is only for those people who attended the class on that day. If you don't attend, I don't give you the marks. Okay, it's only in class. That means I want you to do it in class at 5 o'clock, at 3 o'clock, something, you know, like that. Right? If you don't do, you submit, that's good, but no marks. Okay, now I would like to look at your names. I already informed you. Okay, you have to put in your names, write down the names in Zoom. Okay, Zoom, which is for the attendance, and also Classroom. All right, which is for the work that we do in order for me to give you the marks. So I ask you to write down your names in terms of your first, your second. If you don't have space, that means you can miss your third name. No? That will be fine. For example, ini Siti, Nur Farhana, Natasha. So this is how you should write down your name. All right, your first name, your second. This is the most important. All right, most important. This is the second most important. Your third name, if you don't write, that's okay, because your class list, okay, will go according to that name. Siti, apa tadi? Mana dia? Siti Nur Farhana. Okay. Now there are a few students who put your second name first. So instead of you write Siti, you say Nur Farhana. So if you do that, penatlah saya, to locate your name, because your name in the list is not Nur Farhana. Your name in the list is Siti. Okay. So you put down your first name first, second name, and then third name. You miss your third name, that's fine. Okay, binti tak payah letak, tak apa. And then if you want to, you can write down your metric number. Tapi tak payah, sebab apa? I have only one section here. So this is the only class. So I don't need that. But if you want to write your section number, that is fine. Okay, now I give you example. There are one or two students, all right, who you need to do some correction. Number one, okay. This is just example, all right. Maybe there are other people, because I haven't done the correction yet. Okay, nih, Hatim nih. Okay, Hatim, are you here? Hatim, are you here? Oh, you are not here. Okay, Hatim nih. Saya cakap apa guna kalau dia tak ada. Hatim, are you here? Okay, Hatim, there is what? This is not your full name. What is your full name? What is your first name? Lagi seorang ni, Haziq. Haziq, are you here, Haziq?
Yes, sir.
Okay, Haziq, what is your full name?
Muhammad Haziq.
Muhammad Haziq. So you should put M. Dulu, M-U-H. You can put M-U-H or M-U-H-D, so that when I look at the list, I will go to M right away. If you just put Haziq, then you are wasting my time, because I go to H and I don't see your name there. And then, are you Ahmad Haziq or you Muhammad Haziq? Or do you exist at all in my list, in my class? Okay, so for those people who didn't do your full name as per requested, I did that. I think I already informed this a few times. But there are still people don't understand. I do not know. Do you purposely don't want to do that, or do you have problem understanding what I say? So if you have problem understanding what I say, you can WhatsApp me. All right, you can WhatsApp me, ask me what did I say. Okay, but if you purposely don't want to put, then okay. So if you continue to do that, I will deduct marks. Okay, for my time, I will deduct your marks. Whatever marks you get, I will take away a few points because of my time. And it's not very difficult to follow the simple instruction. It's not that I want you to jump from the fourth floor. I just want you to write down your name as per class list. All right? Okay, nih. Give you another name. Okay, this one. Mana tadi? All right, because this name here, the last name is different than the name that you write down here. Taha, are you here? Taha, what is there is a name?
Yes, sir.
Your name has Taha.
Yeah,
Okay.
Taha.
Taha.
My name.
But your name, Taha, it doesn't come the first one. Your first name is what?
Abul Aid, right?
You don't know your first name?
No, Abul Aid. I thought.
So you write down Abul Aid. Okay?
Because this is my family name.
It doesn't matter your family name or whatever name. What did I tell you? I tell you, first name in the class list, whatever your family name, your uncle name, your son's name, doesn't matter. You do it as class list.
Understood.
Okay? Your class list, what is the first name that comes? No, Taha. What is the first name that comes?
Abul Eid.
Abul Aid. So I told you, when you write your name in the Zoom or classroom, you follow that class list, regardless of, which one is your family name or whatever. Okay, it doesn't matter who is your family name. Since we just want to be consistent with what? With the class list. Okay, so for those people who are non-Malaysian, all right, sometimes your names, especially if you come from the Middle East or India, Pakistan, sometimes your name is different than the normal order of your name in UIA. I do not know how you did it, but we follow your name as the order of what? Order of the classes. Okay, so yours is one example. Probably there are a few more, non-Malaysian. So just do the correction. Okay, do the correction in Zoom and Classroom. Put your name as per the class list. Okay, Ta, are you clear?
Yeah, okay,
Alright.
sir. Already.
Okay, thank you.
Okay,
So
sir.
make sure you do that as soon as possible. Okay, if possible today. Okay.
Yeah, I already done.
All right, good. So what we do now is we are done with the homework. I make my announcement. We go back to our discussion. Where is it? I think we are done already with the chapter 4. So the chapter 4, we only do 4.1, 4.2. We are doing only the graphical method, the optimization problem. Okay. All right. Before we move on, any question, any problem with that chapter? No. All right. So the next topic would be what? The next topic would be the derivative. So derivative is chapter number 9. So let's go to chapter number 9. We want to do derivative. We are to discuss today the concept of a derivative. Okay, of course, derivative can be complicated, but we just want to have an idea, all right, an idea of a derivative, basic idea for the purpose of our course. So we just want to do it the basic idea. So we don't worry about 9.1, 9.2. I think probably a little bit of 9.3. I think we start at 9.3, but the formal beginning point is 9.4. Okay, so 9.1, 9.2, don't worry about it. Now, what is derivative? Okay, derivative is how should I say derivative? Okay, derivative of a function. If you consider a function, a general function, consider y equal to f of x, right? Now, the derivative is the following. The derivative of y equal to f of x is, I'll give you the notation. Okay, this is the notation, how we write it down, is y prime equal to f prime of x equal to dy dx. So that's the notation. Either you write y prime, so this is y prime. Okay, that thing on the top. Here is f prime. Okay, we say f prime. And this one, we call it dy dx. Okay, dy dx. So that is the derivative. Now, what is the derivative? Okay, what is it? So in order to do that, I will start from here because this notation, dy dx, make a little bit sense to us. Now, you could look at dy dx. dy dx is approximately, okay, related to something that we learned already, delta y, delta x. Now, what is delta y, delta x? Do you remember what is delta y, delta x? What measure does it give us, delta y over delta x?
Slope.
The slope. So delta y, delta x is equal to the slope. So dy dx, the derivative, is what is related to the slope. Okay, so related to the slope. Now, how is it related? Okay, this is what we this is our approach. So the derivative is related to m equal to delta y over delta x, which is the slope of y. Okay, this one we use, if you go back to chapter 1, we do this for linear function. All right, a linear function, you got delta y, delta x, you are given 2 points. And how do you measure the slope? You just take the difference, y2 minus y1 divided by x2 minus x1. The derivative will be derived from there. Okay, so the derivative from here, you will get dy dx. I'm sorry, dy dx. How do you do that? You make the delta x smaller. Okay, smaller and smaller. So that is our idea of the derivative. Okay, derivative is essentially or basically the slope of the function, all right, of the function as you make delta x smaller and smaller. So let us look at more detail into that. Now we look at the general case. Okay, general case, the function is non-linear. It's not linear. That means the function will be not a straight line. What we did so far, all right, we do this. We have a straight line like that. Okay, y equal to f(x), straight line. And if you recall, I have the first point with x1, y1. And then I have the second point. We call it x2. We can call that point A and that point B. So as you know, the delta x will be the change from x1 to x2. So that is delta x. Delta y is the change y1 to y2. So you have delta y over delta x. So the m is equal to delta y over delta x. And that will be what? That will be the slope, okay? The slope of the straight line AB. So that will give you the slope of the straight line AB. And of course, it's a linear function, it's the same everywhere. So you can extend the line up to whatever you want, okay? Constant slope. Constant slope. So we know the slope of a linear function, okay? Now, suppose we have a non-linear line. Suppose we have a non-linear line. Say it would be something like this. So that passes through B. Okay, I missed B. So it should go through the point B. All right. So if you look at the curve, call this, okay, here I say y equal to f of x. Call it y equal to f of x for y equal to f of x. Now, if I use the slope m equals delta y delta x, you get the ratio delta y over delta x. The slope would be what? Would be the slope of the straight line AB. Now you have the curve. You have the line in the red color, pink. Okay, red color, red line. Now, does it measure the slope of the curve? The straight line AB, is it the slope of the curve from A to B in pink? What is it? It is not. Okay, no. Why? Because the slope of the line is the straight line AB. The curve AB is the line in red. If you look at the slope straight line and the curve, they are not the same. Okay, so it is not. So it's delta y over delta x is not good. Okay, it's not good measure. Okay, it's not good measure of what? Of the slope of y equal to f of x between A, B. So what do we do? Question is, what do we do? Okay, what we do is, if you remember what I said earlier, you make delta x smaller. Okay, so when I do that, suppose I make the delta x changes by only that much, call it x3. So x3 I have here, that will correspond to y3. Call it that point C. Okay, so we make that thing smaller, the change. So what is the change? Delta y? Delta y will be that gap. What is delta x? Delta x will be that gap. So now the delta y is smaller. That will lead to a smaller delta. I'm sorry. Delta x is smaller. That will lead to a smaller delta y. All right. So what is the slope between these 2 points? The slope between the 2 points by delta y and delta x is the straight line connecting A to C. No. Okay. All right. Now, what can you say about the straight line AB and straight line AC relative to the curve? Relative to the curve, the non-linear curve. What can you say from, from the things that we draw here? How do they relate? Just look at the, their position. How do they relate to each other? Okay, I'll do one more. Suppose I make the change in x smaller. Say that point D. Okay, to D. Now I move to x4. So that point here, the y is y4. So that is delta y. Okay, delta y. Delta x is 2, delta y is 2. So delta x is kat sini dah kecil. So very small. All right. Now I make a straight line from A to D. Okay. I have 3 lines. AC, AB, AD. Compare the straight line, the slope of the straight line, and the curve. What can you say? What? What did you say?
Become smaller, sir.
Of course, become smaller. Okay, the gap becomes smaller. That's number 1. Number 2. The straight line relative to the curve. You just observe, just describe what you see. Intercept. Not really intercept, Maybe you have the idea, but it's not really intercept. You just compare, right? you just compare AB to the curve AB. And then AC, the straight line AC, to the curve AC. And then you compare the straight line AD to the curve AD. So you just compare, all the straight lines to the respective red line for the same interval. That means AB, AC, AD. So you compare the straight line, right? The slope delta y over delta x with the curve itself. Okay, how? Well, what can you say?
Steepness.
One is steepness. All right. You see here, the steepness, of course, are different. Okay, that's number 2. Number 3, that is not what I want. Okay, number 3.
Smaller area.
Well, about area. We just want to compare. All right, we just want to compare the straight line for each of the interval AB, AC, AD. Okay, if you look at the lines, all right, they are what? If you look at AB, the straight line and the curve is what? Is very different. Okay, very different, and they are far. Okay, far away. You look at SC. Okay, look at AC. How do you compare AC, the straight line, and the curve? Okay, AB is different. Okay, the straight line and the curve, they are much different. Okay, and they are far away from each other. You use the same approach. You compare the straight line AC with the curve AC. What can you say? Are they still very far away to each other?
Near.
Huh?
Near.
They are nearer. Okay, and they are nearer. And they nearer. That means when they are nearer, the shape, okay, the shape are much more similar. Okay, they are different, far. So you look at C, they are nearer, all right? In terms of different, not so much, it will be less different, okay? Now you look at the other interval, AD, okay? You look at AD, the straight line AD, which I draw in blue, and the curve, the red curve, AD. What can you say about that, about those two? How do they relate now?
Very close.
They are very close. Okay, they are very close. So the slope of the curve and the slope of the straight line, they are much more closer. All right, but it is not exactly the same. Okay, it's not the same, but it's smaller. So by making the delta x smaller, right? You make the delta x smaller. That means what? That means you will get a better measure, okay, of the slope. All right, so I continue to make it smaller until delta x approaching 0, very, very small. Approaching 0 means very, very small. Okay, now when it happened like that, when the delta x becomes very, very small, then what we have will be delta x is much smaller. So I cannot draw anymore. Delta is much smaller. So when you do that, I have to draw another graph. Okay, when we do that, I will draw another graph to show it. When you have delta x smaller and smaller approaching 0, that's the curve y equal to f of x. All right. Now imagine this is point A. That's point B. Okay. And then you have all the intervals in between. So when you make the delta x smaller and smaller, this x1, y1, make the delta x smaller and smaller, what you have will be the curve, okay, the straight line, the slope of the straight line will be what? Will be the slope of the curve at point A. Will be just the slope of the straight line. We call it here M, just tangent to the curve at point A. So that is the derivative, right? So I will write down here, as you make delta x smaller, approaching 0, this is what we have. Okay, number 1, you have the slope of a function y equal to f of x at the point, or here any point, can be any point, okay, at the point A. Since we are talking about A, but it's not necessarily A, it can be any point, okay, it will be the slope of the function f of x at the point A. So here we no more talking about the function or the slope between 2 points. It's what? It's the slope at a point A. Now, what is it? It's the slope. Okay, the slope at a point A is the slope of the straight line. Okay, line just tangent. Okay, just tangent to the curve to y equal to f of x at A. Generally, at any point that we are talking about. Okay, so that slope now, as you make the line delta x smaller and smaller, the slope at the point A will be the slope of the straight line, just tangent to the curve at that point A. So we call it slope at the point. Okay, slope at the point. And what is it? It's the slope of the straight line, just tangent to the curve at that point. And you can generalize at any point. Okay, not just point A, it can be any point. Now, as you make the delta x smaller and smaller, then you have the derivative. Okay, the derivative, y prime equal to f prime of x equal to dy dx. So dx, okay, this one, in other words, it's just to give you idea, the delta x is very, very small, approaching 0. All right, so you are still talking about the slope. Okay, the derivative is still the slope, but what kind of slope? It's slope at the point. Okay, the slope at the point, and then how you measure it? It's the slope of the straight line, just tangent to the curve at that particular point. Okay, so that is derivative of the function. But for us, all right, for us, this is the concept of the derivative that you want. Don't worry about the other things. If you look at the book, they will say instantaneous state of change. Okay, we don't go into that because that will be talking more about the limit. So we don't want to do that. What you want is this thing. If you recall from, if you take physics, you know, in SPM level, if you have a function, okay, if you have a function, y equal to f of x, then that is the distance function. Suppose it's distance function. Now, what is the derivative of distance function? Anybody recall? Anybody remember? You have a distance function. You take the derivative of that function. What do I get? What do we get? You get velocity. Okay, so velocity is the derivative of what? Of distance. So that is what? That is the slope of the distance function at any point. Okay, in other words, that is the instantaneous rate of change of distance. So the derivative is, if you want to put it, is since the delta x become very small, it's the instantaneous rate of change of y. So I think if you remember physics, they talk about velocity, as the instantaneous rate of change of distance. So that is the concept of derivative. And we can find, right, by the same token, we can find the slope at any point. Like I said, you can find the slope at point B. Okay. Now, what is the slope at point B? The slope of the function at point B is just the slope of straight line, just tangent to B. So that is the slope. And I can find the slope at point C. Okay, that's the slope of the straight line, just tangent to C. And if I can continue the line like that, we can also find the slope at point E. That's it. Okay. So how do you get the slopes here? You use the derivative. Okay, use the derivative. All right. Look at the slopes. This one, this one, this one, this one. What can you say about the slope for the curve? For the non-linear function here? What can you say about the slope at this different point? I can find the slope here. In fact, at any point, you can get the slope. Kita bagi satu slope ni. A, B, C, D, E. Never E. Right. What can you say about the slopes at all these different points? What can you say? Tengok M kat sini, slope sini, slope A, slope at F, slope at E. All right, what can you say about the slopes? What are the character of the slope here? Kita boleh buat lagi. Okay, anybody? Katakan point G. All right, what can you say about the slopes? Yeah. Hello. Hello. Are you around? Are you still here?
Sir.
Jangan tak azan lagi ke? Patutlah masuk asam. Alright, what can you say about the slope at each of these points? Give me a general
To the
answer.
point.
Huh? Tengok.
Tangent.
What can you say about the slope? You compare. You
Yes,
make the,
tangent.
what?
Tangent.
Tangent, I already say. I don't want tangent. I want just you look at the behavior of the slope here. Ini. Of course, the slopes are the slope of the line tangent to the curve at that particular point. All right. You go a step further. What can you say about the nature of the slope at each of the points there? Anybody? Haziq, Muhammad Haziq.
Which Muhammad Aziz?
Yang ni Muhammad Aziz dalam screen. Muhammad Aziz with the I. There are two Haziq. One is E. Okay, the other one is I. So the one with I. Dulu I. So betul lah tu Muhammad Aziz Shah.
Yeah.
Dulu I thought one of you is one with E. Dulu
Dua-dua I.
Oh, dulu Dulu Okay, Muhammad Haziq Shah.
Yes.
Yang seorang tu ada tambah lagi Shah. Yang seorang tu tak ada Shah. Alright. What can you say about the slope at these different points?
They are aligned with the slope. I don't know how to say it.
No, you just look at the nature of the slope. You look at this line, that slope. You just
They are
look at this.
perpendicular with the slope.
What?
They are perpendicular with the slope.
No, that is not. No, that's not what we want. I just want to see the character, the behavior of the slope here, What general behavior? What can you say? Okay, Muhammad Aziz yang tak ada Syah. Okay, Noriman, Muhammad Noriman.
Yes, sir.
Okay, what can you say about the slope, the nature? Simple, yeah. You look at this one, this one, this one. You compare this slope here, the slope like me, EF, you compare to the slope A, C, B. How do they compare? Yang ni, dua ni dengan tiga tu. What is the difference? What can you say about the slope here? Yang ni. What can you say about the slope over there?
Sir.
Okay. Yes.
I think it's the steepness different.
The steepness are different. Okay. Here you see steepness are different. Everywhere steepness are different. And over here, A, B, C, what can you say about the slope? General behavior. They are, of course, steepness different. Okay, what do they have in common? Ini. Compare to yang dua ni.
Positive.
Here is positive. Over there, negative. Okay, so there are two things. Positive, negative, different steepness. All right. Now, different steepness, positive, negative, maybe different steepness is more general. All right. Different steepness, that means for a non-linear function, okay, for a non-linear function, the slope, okay, the slope at any point, any 2 points, at any point, all right, are different. They are not the same. Okay. So here, in terms of steepness, you can see, different steepness compared to the other side. So they are different. All right. Linear function, the slopes are the same everywhere. All right. So that is another use of the derivative, because the slope of nonlinear function are different at any point. So by making use of the derivative, we can handle that thing. You can still determine the slope at any point by using the derivative. Okay. Okay. We're going to look at it. Now, derivative is the function. All right. Derivative is the function, is the noun. The derivative of y equal to f of x is y prime equal to f prime of x. Now that is the name. Okay, you call it noun, name. Now the process of taking the derivative, we say differentiate the function. Okay, differentiate y equal to f of x. You get the derivative. So differentiate here is the verb. Okay, the process. Right. So that is the idea of derivative. Okay, we will continue after the other. All right, Assalamualaikum. Okay, we continue. Okay, what do we do next is that given that idea of derivative, what you want to do next is how do we find it? Okay, how do you find the derivative? Okay, our life has been made simple. You don't have to do much, because it's a system. We just need the different rules. So what we want to do next is we just look at the rules of derivative. And in order for you to find the derivative of a function, we apply the relevant rules. So there are a number of rules. So the rules of derivative will start from 9.4. So you look at 9.4, there will be different rules of derivative. So this is the starting point for us. We will look at the rules of derivative. So 9.4, the rules of derivative. So let's do that. So you go to 9.4, we go look at the rule, rules of derivative. So you apply the rule in order to get the derivative. So you consider a function, all right, y equal to f of x. We want to find the y prime or f prime of x. So this is where we will start. I show you the rules. Everything here is in the book. Okay, so I just show the rules here so that I don't have to write these things. Now, first rule is you have a function on that form. Y equal to, or f of x equal to x to the power of n. Now, this n here is not integer. This n here is real number. So it can be 2.5, it can be square root, it can be 1.34, it can be 1 over 2, things like that. Now, what is the power rule? The power rule is the following. If I have f of x or y equal to x to the power of n, what is the derivative? The y prime or f prime is just equal to what? Equal to n multiplied with what? With x, reduce the power by 1. You multiply with x, n minus 1. Simply mean reduce the power by 1. Okay? All right. So an example will be if y is equal to x to the power of 10, then the derivative I can use y prime equal to 10. You bring down the power, multiply by the x, reduce the power by 1. So that is 9. Okay? Or if I use f of x to denote the function, let's say f of x is equal to x to the power of 3.8, then what is f prime of x? That will be just equal 3.8, okay? Because it since it involves decimal point. So it's good to put the bracket. You multiply by x, reduce the power by 1. X 3.8 minus 1. What do I get? 2.8. Okay. All right. So this is the first rule. We call it power rule. So there are a few more examples in the book. So I just go through this quickly. I did this. Okay, something like this we already done. All right, here, example number 2, B. I have P equal to Q to the power of 2 over 3. Okay, what is the derivative? You bring down the power 2 over 3, reduce the power by 1. So you have 2 over 3 minus 1. 2 over 3 minus 1, what do we get? Negative 1 over 2. Okay, so derivative is 2 over 3, Q negative 1 over 3. Okay, all right. Okay, so here, C, you have a square root of t. The function C equal to square root of t. Now, what is the square root? What is the value of square root? What is the power? What's the value of the power of square root? Berapa?
1 over 2.
1, 2. So what we do, we use 1 over 2. So I have y equal to x to the power of, okay? And then you get the derivative. The other example is they use 1 over square root of x. Here x equal to 1 over square root of t. So how do you do that? You have to bring that up, okay? So you have to bring that up. I got y equal to 1 over t to the power of half. So you can bring that up. That will be equal to what? Equal to t to the power of negative half. Because here you have only 1, right? Let's say you have 4. Then of course now you have 4. Okay? And then you do the derivative. So what is the derivative? S prime equal to 4. Okay, I make the 4 here. 4. Then multiplied by a negative half, you bring down the power. Multiplied by t, reduce the power by 1. So what is it? Negative 3 over 2. So we stop there. Or you can simplify the constant now. So that will be negative 2 t to the power of negative 3 over 2. So that's it. All right. So that is the power rule. Okay. Okay. Next. Next rule is the what rule? Constant rule. Constant rule. Mana dia constant rule? Derivative of a constant rule. Okay, so we call it constant rule. So constant rule, you have a constant function. Y or f of x equal to c, where c is a constant. Okay, so what is the derivative of a constant? It's just 0. So any constant, you take derivative, that will be 0. Okay, so that is what you call constant rule. Example, let's say I have y equal to 100.45. What is the derivative? Y prime 0. Okay. Okay. So that is called the constant rule. So constant rule f prime 0. Very trivial. Okay. Very straightforward. That is the most basic rule. Okay. Next rule. Okay. Next rule is what you call the coefficient rule. Coefficient rule, you have a function. You have the constant here, c, a constant, multiplied by a function of x. I think function of x, easy cheater is terms in x. You have some terms in x over here, u of x. Now, how do you differentiate that function? It's just what? So you just have c multiplied by the derivative of u. Okay, so you don't worry about the c. The c will just follow the derivative. Okay, the constant will just follow the derivative. So this is what we call the coefficient rule. I'll give you an example. For example, here, let's say I have y equal to 21 x to the power of negative 7.8. So you don't worry about the constant. The constant will just follow the derivative. So we got y prime equal to 21. You just write down 21. You can put a bracket there. Okay, and then we just apply the power rule to differentiate the x term. So what do I get? I get negative 7.8 multiplied to the x, 7.8 negative minus 1 is negative 8.8. Of course, you can multiply the two things, you get some value. Okay, so that's why we call it coefficient rule, because the constant will just follow the derivative of the term in x. Okay, all right. So I think they have a few more example here. Okay, example 4, x over 5. So the constant, okay, will just follow the derivative. So derivative is 5x over 4. So you got 20x. So same thing here. Okay, all right. Now constant rule. Next rule is the derivative of the sum or n or difference. Now what do we have here? We have, just look at the sum rule, correct? Difference we do afterwards. Just look at the sum. Sum means you have addition of two or more terms in x. You have u plus v, where u are terms in x, or u is function of x. V is also a function of x. So what is the derivative? Okay, you look at the derivative. What is the derivative of u plus x? Just read the formula. What is the derivative? Okay, anybody? What does it mean? Yeah.
U prime
U prime.
x
Okay,
plus
u
v
prime. And then what?
v prime.
And then v prime. And then you add them up. Okay, so what we do here, you differentiate each of the term. So you got u prime plus v prime. So that is the sum rule. You differentiate each term and then add them up. So here you can have two or more terms in x. Okay. Or in the formula they give you 3, but it can be 3, it can be 4, it can be 5. Okay, so don't worry about the number of terms, as long as what? As long as they are added to each other. So what you do here is you just take the derivative of the first plus the derivative of the second. And if there is another term, you just add the other derivative. Okay, the other derivative, whatever it is. So that is what we call the sum rule. So you have just to focus each term at a time. Okay, each term at a time, you differentiate each term at a time. And then add them up. Okay, all right. Any question? Okay, good. So let's go on. Let's look at an example. Okay, here there is a negative sign. Okay, afterwards, when we do the difference, maybe we can come back here. You can look at the first part, 3x plus 5. So you got 3x and 5. So there are two terms in x. So what do? You differentiate 3x. Okay, maintain the positive sign, the sum or the plus sign, and then I differentiate the second term. So what do I get? What you differentiate 3x, what do we get? You got 3. Okay, differentiate 5, constant. What do I get? 0. So what is it? 3. Okay, so let's look at some question in the book, because I just want to see. We just look at the addition. Okay, so I think I'll give you an example. Just look at the addition. Suppose I have 5 f of x equal to 24 x, the power of 21 plus 2.5 x to the power of negative 10.5 plus 100 x, okay, plus 299. So you don't worry how many terms there are. What we do is what? Differentiate each term and then add with the other terms. So you differentiate. Okay, So what is the derivative of this function here? What is the derivative of the first one? Okay, I'll give you 1 minute to do this. You differentiate each of the terms and then add them up. Okay, you got it? The first person who finished, just let me know so that we will continue. Okay, dapat ke belum? Okay, the first person who got it, let me know. Cakapnya dah siap. Okay, there is one student who have not put their picture yet. Ni, Hima. I want you to put in your picture. Okay, everybody else have done it except you. Semua orang dah buat dah. Ni seorang je lagi belum buat. Oh, ni lagi seorang. Abdul Latif. Okay, put your name, put your picture here. Okay, because like I said, I don't see you. I want to see how you look like. All right. So put your picture. If you don't, okay, by next time I will deduct marks for any of your work. Okay, you got the derivative?
Yes.
Okay, good. So what is the derivative? You just differentiate each of the term and then add them up. So what is the derivative of the first term? You got 24 multiplied by 21. Okay, and then you reduce the power by 1. So that's it. So maybe you can multiply that thing plus 2.5, right? And then you multiply by 10.5 negative. And then x, reduce the power by 1. There will be negative 11.5 plus 100x. There will be just 100. And then you got the constant 0. So that's it. Don't worry about how many numbers there are. Okay? Okay. Now, by the same token, we have the difference rule. The difference rule would be the same idea, but now we have minus sign. All right. So instead of you have u plus b, I have u minus b. Or it can consist of more than 2 terms. So here I have y of x, y equal to say u minus b. All right. Or you can have minus whatever. So same token, y prime is equal to what? Y prime is equal to u minus u prime minus b prime minus whatever terms that you may have. Okay? Or you can have a negative sign here also, that's fine. Okay? Because it's a fraction. So if I use the same example here, okay, same example, but now that becomes negative sign. So everything same, okay, except the signs. Everything else, okay, the derivative rules are the same, only the signs are different. So this is the difference. All right. Now, having said that, if I have here, you look at 1 or 2 examples, they have one function here. You have plus, plus, and then you have minus, minus. So it doesn't matter. They can mix up. All right. You can either have plus or minus sign, same rule. Okay. Differentiate each term. Keep the sign as it is. Okay. If it is negative, it's negative. If it is positive, maintain it as positive. And then only you multiply by the derivative of the term. Okay. All right. So that is an example. Okay. All right. Any question? Okay, I will give you some homework problems for your practice. So homework is basically 9.4. Okay, 9.4, you just practice all the rules that we just learned. 9.4, you can do from number 14. No, I'm sorry, not from number 4. Number 4, you can do up to number 14. You don't have to do all. Okay, do some. All right, as many as you want until you feel comfortable. And then we can do number 15 and also 15 to 17. 15, 16, 17. Okay. All right. Now is 4:45. I have 5 more minutes. So 5 more minutes. I would like to look at the derivative. Okay, how we use derivative to get the slope at a point. Okay, how we use derivative to get the slope at a point. In other words, this is something that we do as in the graph here. Okay, something like this. Okay, so let me give you an example to show that. So here, let's say we consider a simple function y equal to x squared. Okay, now y equal to x squared, what is the derivative? Y prime is equal to what? Is equal to 2x. So that is derivative. So we can use that derivative to find the slope. Okay, at any point. At any point. And the slope is what? The slope is the slope of the line, the straight line, tangent to the curve. Okay, tangent to y at that point. Okay, all right. So let me do that. So let's sketch the graph of x squared. Now, if you remember, how does the function x squared look like? It will look like this. It is a curve. We're looking at that. Okay. Now, I want to find, okay, I want to find slope. Say at x equal to 1. X equal to 1, of course, you know y is also equal to 1. So that's the point here. X equal to 1 and y need 1. Okay. Now I want to find the slope at that point. Okay. So how do I do that? I use the derivative. So what you do, easy. Substitute x equal to 1 into what? Into y prime. What do I get? Y prime is equal to 2 times 1 equal 2. So the slope at 1, at x equal to 1 is what? 2. How do you show that? It's the slope of the tangent line to the curve at that point. So what you do, in order to show 2, you just draw the straight line tangent to that point for the curve. Okay, so that is the slope, m equal to 2. Okay, all right. Now I can do that for another point. Suppose I want to find the slope here at x equal to 5. So what do we do?
Okay.
X equal to 5. You know the y is here 25. Okay. How do you get the slope at x equal to 5? What do we do? Okay, find the slope at x equal to 5. What is the value of the slope? I mean derivative lah. You get the derivative. What is the derivative at x equal to 5? What is the value of the derivative?
10.
10. Okay, 2 times 5, 10. Again, here you substitute. So at x equal to 5, at x equal to 5, substitute again into what? Into y prime. So I got y prime equal to 2 times 5 equals 10. So the derivative of the function x squared at 5 at x equal to 5 is 10. So how do you show it as the slope? It will be the slope of the straight line just tangent to that curve at point x equal to 5. So that is m equal to 10. Okay? And of course, you can find also here, say -2. All right? So if it is -2, what is the value of the slope? Quickly. But now we can do it quickly. You don't have to substitute, just do it.
-4.
-4. So what is the -4? It's shown by the straight line, just tangent to that point. Okay, just tangent to the curve at that point, x equal to -2. So what?
So we can find it in any point.
Yeah, you can find any point. So you can find at any point. So that's why I said, find the slope at any point. What is it? The slope of the line tangent at that point. Okay, so you can find x equal to -5 or x equal to whatever the value you want. You know, there are so many points, infinitely many points over there, up there. Okay, and you can see here the function is non-linear. You see the slope. Okay, they are not the same at any 2 points. They are different. So that's why we use the derivative. Okay, we use the derivative to get this. Okay, all right. So to get this idea better, you do question number 15, 16, 17. Or if you want to do number 8. So for that 17 to 15 to 17, you just do part A aja lah. Okay, just do part A. Don't worry about the instantaneous state of change because that will involve limit. That's beyond our scope. Okay, so we just do what we're doing now. Okay, apply the derivative principle. Okay, all right. Any question? Anything?
Nope, sir. All clear.
Okay, all clear. Good. So I will stop here. I will see you again Wednesday. Have a nice day.